So here's the big picture. We're just going to try to, I'll let you pause and look at it if you like. Right now we're just going to try to prove that this thing here, the green thing, is less than epsilon over 3. And basically it's going to be true for all n bigger than or equal to some capital N1 to be named later. So let m and n be any natural numbers. Define these functions fm minus fn and temporarily fix any x in there. By the mean value theorem on Cx, there exists an alpha such that f prime m minus f prime n evaluated alpha is equal to fm of x minus fn of x, which is really my h evaluated at x minus my h evaluated at c. That should be an m c minus f n of c over the length of the interval. Right? Now the great thing here is that these f primes converge uniformly to g. So since fm prime converge uniformly, since they converge, we can use the Cauchy criterion in particular. Cauchy says there exists an n1 belonging to n such that for all m and n bigger than or equal to n1, this is the n1 that I'm going to get from the theorem, I get a couple things. I get fm prime of alpha minus fn prime of alpha less than epsilon over 3 for all alpha belonging to AB. So maybe alpha wasn't the best choice, but it certainly works for the alpha. So basically it really gives me f prime of x minus fn of x for all x, but I'm just going to plug in alpha. So I know that this is true. And now this is equal to that. So I can just substitute this in. So I get f x. So now it's not any old m and n. It's m and n bigger than or equal to this n1 minus fn of x minus fm of c minus fn of c all over x minus c is less than epsilon over 3. So this almost looks like what I want for the green thing. The problem is that I don't want the m's in there, right? I have two subscripts and I only want one. And I have a typo here. I have a couple typos here actually. No, I don't. Just kidding. This is actually equal to, right? I have fm minus fmc, fnx minus a negative fnc, so I can split these up according to fmx minus fmc minus fnx minus fnc. I'm just doing algebra here over x minus c has to be less than or equal to less than epsilon over 3. Okay. I'm going to stop the podcast, the screencast here, and then I'm going to end up erasing a lot of this and then kind of showing you what happens next with the order limit theorem. So stay tuned for that in podcast 3, screencast 3.